All right, this is going to be section 1-7, midpoint and distance in the coordinate plane. So this is going to be quite a review for some of you. This is going to be a lot of algebra formulas that we're going to do in this section. So quickly, let's do some vocabulary review. So we're going to use a figure at the right. Notice this figure, by the way, is drawn in the coordinate plane. So we're going to start bringing this together. All right, so points A and B are both at the origin. Is that true or is that false? Well, only point A is at the origin, so this is false. All right, if AB equals BC, then B is the midpoint of AC. Well, that's true. That's the definition, isn't it? The midpoint of AE is F. Is that true or is that false? Well, that's false. It's not halfway between it. The Pythagorean theorem can be used for any triangle. That's false. The Pythagorean theorem could only be used for right triangles. Point C is at the point 6, 0. That's false. It's at the point 0, 6. And point E has a y-coordinate of -8. That's incorrect. That's also false. It has a y-coordinate of 0. It has an x-coordinate of -8. Okay, so definition. The midpoint of a segment is a point that divides the segment into two congruent segments. All right, so using your vocabulary, the midpoint of EF. So where is EF? EF is right there. Halfway between it is G. And that point is about 0 on the X and 1, 2, and a little bit more, 2.5. The midpoint of AB, so AB, midway point is right there in the middle, so how about 0, 0, or the origin? The midpoint of CD looks to be right about here, so we go over about a 0.5 and up 0. Okay. So on the number line, the coordinate of the midpoint for M of AB with endpoints A and B is this formula. So if I'm just looking in a number line, one dimension, to find the midpoint, we simply do A plus B over 2. In the coordinate plane with XY coordinates, we do the midpoint formula here. We take the average of the X's, comma, the average of the Y's. Okay. So let's find the midpoint of the following segments. If they have endpoints 5 and 9, what we simply do, if you take 5 plus 9, divide by 2. So 14 divided by 2, that's how we get 7. All right, -3 plus 5 divided by 2. So we get 2 divided by 2, we get 1. -10 plus -3 over 2, we get -13/2, which is the same thing as -6.5. And we have -8 plus -1 over 2, so we get -9 over 2, which is -4.5. All right, let's complete this diagram. So here's the midpoint of this figure. So X is 1 plus 17 divided by 2. That's 18 divided by 2, that's 9. All right, 2 plus 4 is 6, divided by 2 is 3. There we go. All right, let's find the midpoint. So the midpoint AB has the coordinates 4, -9, and point A has the coordinates -3, -5. What are the coordinates of B? So we're going to work kind of backwards in this type of problem. So what I do know are the endpoints of A, which are -3, -5, which would go into my formula here. Notice I don't know my other point for B, but I do know my midpoint coordinates, which are 4, -9. All right, so let's substitute some values in. So this was -3, this was 4. So we have multiplied by 2 on both sides. We have 8, add 3, and we get 11. All right, over here, we have the -5 from this equation here. Bring down the -9, multiply by 2, so -5 equals -18. I add 5, and I get -13. So my midpoint is 11, comma, -13. Or my other point is 11, -13. All right, how to use the distance formula now. So here is the distance formula, and it's actually derived from the Pythagorean theorem. You need to know this formula. You need to memorize it. So here it is. If here is a segment, a distance, we can define it as coordinates, x1, y1, x2, y2, and it's the same as the Pythagorean theorem. A squared plus b squared equals c squared. So I take the difference in the x's squared plus the difference in the y squared, and that's going to equal the square root of my hypotenuse. So in the diagram above, draw a line from each side of the triangle column A to the corresponding coordinates. So y2 minus y1 is the same as side B. x2 minus x1 is the same as side A, and the distance d is the same as side C. So let's actually use the distance formula now. So here's the distance between -2, 14 and 3, -1. Complete the diagram at right. So we want to first find the difference in the y's. So -1 minus 14 is going to give me -15. The difference in the x's, so 3 minus the -2, is going to give me a 5. All right, so let's use the distance formula. So the formula is x2 minus x1 equals y2 minus y1. Plugging in the values. X2 coordinate was 3 minus -2 equals -1 minus 14. This value here is 5 squared plus -15 squared. So this value here is 25 plus 225, and this equals 250. Now for this class, it's okay to use a calculator and approximate. So we have 15.8 is our answer. And that is how we use the distance formula. Okay. Now, how can we use this in real life? So, finding distance. So let's suppose I'm on a zip line course and we're harnessed to a cable that travels through the tree tops. So you start at platform A, so we're right here on platform A, and we zip to each point. So we're flying around in this little field. How far do I travel from platform D to platform E? Each grid represents 5 meters. So we want to know how far is it from D to E. So what we could do is we could finish this triangle if we wanted to, find the lengths and find the distances. Okay, so step 1, we wrote the distance formula. All right, what did we do next? We substituted in the coordinates for each one of those points, right? Now, what we are going to do next is, looks like we're simplifying, aren't we? So we take the 30 minus the 20, we get the 10. 15 minus the 20, we get -35. We square both of those values and we add them up. Now we're going to use the calculator and we get approximately 36.4 meters. So that's the distance from D to E. All right, let's summarize. So a radical symbol with no sign in front of it indicates a positive square root. So if I just write the square root of 4, that's understood to be just +2. In an algebra class, if I wrote x squared equals 4 and I took the square root, then my answer would be plus or minus 2. I would have 2 answers. So in geometry class, when I just write a radical like this, I'm understanding it to be just a positive. Okay, so how does this formula ensure that the distance between 2 different points is always positive? Well, it's because the distance, the radical in the distance formula represents a positive square root. All right, and that is the end of this section.